Students, we are given this question, dy over dx positive 2 times y cot x is equal to 3x squared cosecant squared x. Now, I can rewrite this as rewriting. This is dy over dx positive 2 times cot x times y is equal to 3x squared cosecant squared x. Now from here, this is of the form. So what is this form? This is of the form dy over dx positive p times y is equal to q, where my p is equal to 2 times cot x and my q is 3x squared cosecant squared x. So the integrating factor is e raised to the power integral p dx, which is e raised to the power integral 2 times cot x times dx. Now, I would just consider integral 2 times cot x dx. I would rewrite this as 2 times integral cot x dx. Integral of cot x dx would give me log of modulus sin x, which I can rewrite it by moving the 2 as log of modulus sin squared x. So I can always change it, right? Because of the fact that a times log b is log of b raised to the power a. By this fact, I can do this. Now, this is, you don't need to place a modulus sign now, so that you can just simply write it as log of sin squared x. Now, the integrating factor, therefore, e raised to the power integral p dx is nothing but e raised to the power. In place of integral p dx, you substitute log of sin squared x. The log and the e gets absorbed or cancelled, giving me sin squared x. So this is what I'm getting. Now the general solution is y times e raised to the power integral p dx is equal to integral q times e raised to the power integral p dx times dx, positive arbitrary constant c. You have got this. So now you have to obtain what is integral q times e raised to the power integral p dx. So we will do that now. So we would substitute the values with the integrating factor information. So that would be y times sin squared x is equal to integral. Now the value of q has been obtained from the question, which is 3x squared cosecant squared x. So place that. So this is 3 times x squared cosecant squared x times e raised to the power integral p dx. That one has been found to be as sin squared x. Okay, we have already obtained that. So plus, first, then you have to place the differential operator followed by the arbitrary constant c. So this is rewritten as y times sin squared x is equal to 3 is a constant, take it out. So this is x squared times cosecant squared x. I can write cosecant squared x as 1 over sin squared x. You got a sin squared x there, place that with the differential operator dx and the arbitrary constant c. Now clearly you can cancel sin squared x, and then that would give you y times sin squared x is equal to 3 times integral x squared dx plus arbitrary constant c. You integrate this, you get x to the power 3 divided by 3 plus arbitrary constant c with y times sin squared x on the left. Now I don't want y times sin squared x on the left. I can always divide by sin squared x both sides. Now when I do that, I get y times sin squared x divided by sin squared x is equal to, now the 3 that you see there can be cancelled, so you would have x cubed divided by sin squared x positive c divided by sin squared x. Now you know that 1 over sin x is cosecant x and 1 over sin squared x is cosecant squared x. So by this fact, right, you can use that fact and rewrite the solution as y is equal to x cubed times cosecant squared x positive c times cosecant squared x. So this is the final solution to the question.